Now that we've learned how to get the data into the right form from a table in our data warehouse to our user item interaction matrix through mapping business-centric values to row and column indices, do we need to implement the ALS algorithm from scratch to be able to use it and learn the user and item embeddings? Thankfully for us, TensorFlow has the WALS matrix factorization estimator to take care of most of the work to create our recommender system. As with all canned estimators, we just need to connect some of the piping, such as input functions, serve and input functions, and the train and evaluate loop, and the estimator will take care of everything else. Because the WALS matrix factorization estimator requires whole rows and columns, we have to pre-process the data from our data warehouse to be of the right form, namely into a structure that we can store into each sparse tensor for rows and columns. Here's an example of our pre-processing step for columns, since we are grouping by item ID. We will have similar code for rows, where we group by user ID instead. So we want sparse tensors, a hierarchical data structure. What file type should we write our pre-processed data to? Here we are storing two arrays. It's kind of painful to do this in CSV, and inefficient to do it in JSON. Therefore, our best option will be to use TensorFlow records. And look, it's fairly easy to do in Python. Here we create a TF record writer with our specified path, users for item, in this example. For each item, we want to create an example that stores our features, which we can then write out as serialized examples to our output file. Sparse tensors are hierarchical data structures where indices and values are stored, which in this case will be the user IDs, or the index of the users, from the user item interaction matrix, and the ratings, respectively. We will also store the key, which is the item index, from the user item interaction matrix. This value is important to save, which we'll see later, because during the batching, the first dimension of the sparse tensor, indices tensor, with rank 2, becomes the batch indices instead. So we'll need the key data to replace the incorrect overwrite when we're done with the batching phase of the input function. The indices and values can be quickly converted into a sparse tensor using tf.sparsemerge, where you need the IDs, values, and the vocab size, such as the number of items in this example. Now that we've learned how we should pre-process our data for WALS, let's test your knowledge. If we want to recommend items for a user when we are writing out to the TF record file, our key train feature should be blank, our indices train feature should be blank, and our values train feature should be blank. Choose the answer that best fills in the blanks. The correct answer is E. Because we are recommending items, note the plural, for a user, note the singular, we are in a situation where each example will be a unique user per row. There will be a variable number of items per each user, which will be the columns, based on what that user interacted with. Some users interacting with only a few items, and some users interacting with many items. The indices tensor will be the item indices, or item IDs, that I've interacted with. And the values tensor will be the corresponding ratings at those user item interaction points within the user item interaction matrix. Answer A, however, should look familiar, because that is the example we just went through, which is for recommending users for an item.